Yeah, that's great. Good. Okay. Hi, and welcome to this live streaming session on RBN1 Tube. I'm still very new to this. I've been spent a bit of time setting things up, and each time getting a bit further nearer to what I want to actually happen. What I intend to do today, is, as the name at the top of the screen says, is to use Sonic Pi playing some Bach, and I'm using a Raspberry Pi for the source of my Sonic Pi, and you can see the screen in front of me here. And um, if I just grab the right mouse, we can actually come up here and show you just perhaps one or two new features of this version of Sonic Pi, which is 3.2.1, which is running on the Raspberry Pi 4, as I say. The way you're getting the picture is that I'm actually using a program called VNC Viewer, which is running on my Mac, and the Raspberry Pi screen is being transmitted to my Mac, where I'm using OBS software to produce this live stream. But it's pretty responsive, and so it should work for us. Just to show you one other new feature in Sonic Pi on Raspberry Pi, and that is that we now have a transparency setting which works on the screen, and you can see that I've now actually reduced the transparency to zero, and so we've got everything running. And we can just perhaps test the sound on this and run up one of the examples that comes with Sonic Pi, which is Tilburg 2. Here it goes. You can also see another new feature. I'm just going to come down here and reduce the volume a bit of the output from there. That's a bit better. You can hear me and hear the sound just in the background, which is coming from the Raspberry Pi. And the other new feature which I wanted to show you, if I just turn the preferences off, is one of the new scopes which are built into this version of Sonic Pi. And this one gives you as audio spectrum, showing the energy across different frequencies, low frequencies on the left, high frequencies on the right. It's on a logarithmic scale, so you actually get more built in down the bottom end than you do up the top, but it shows visually everything that's happening very well. And it's a stereo display, so the pink is the right channel and the blue is the left channel, and we can see that perhaps in some experiments later on, just to show how that works. Now, often when using Sonic Pi, many people will do live coding. I'm afraid my typing is absolutely abysmal, and I tend to use Sonic Pi more for linear pieces of music where I write the whole thing and then play it, although we can actually look at things like live coding as well. So if we just stop that playing, which I'll do now, and then we move down a bit. Because this is very new to see streaming like this on Sonic Pi, what I'm going to do is to I'm just playing around trying to get to the screen where I can actually see what I want to see. There we are. What I'm going to do is just to go through how this actually arrived here, because this version of Sonic Pi is not available on Raspbian, but it is package that I've done, and it is available to anybody who wants it on my Raspberry Pi. If I move up to the top here with the cursor and I bring the the web browser to the front, you can see on here, let me just get rid of that screen up here. I'm sorry, I'm still getting very there's so much going on my screen here, it's unbelievable. I've only got one monitor, and so I've got to get everything going at the same time, see everything's working okay on the broadcast, but also look at the screen that we're actually interested in, which is this one. And so this is running the Chromium browser that comes with Sonic Pi. And if I just go back a previous page on this, we're looking at a site which is actually set up in Switzerland, believe it, although my home is actually in the UK. But my son lives in Switzerland, and he purchased the domain Neumann.ch because there aren't many Neumanns in Switzerland, one or two Neumanns, but no Neumanns. And so it was relatively easy to acquire. And I've got a website set up there with the URL r.newman.ch, and I've put on the top of it a URL which you can see here, r.newman.ch /RPI /server, sonic pi 3.2.1. So that's r.newman.ch /RPI /sonic pi 3.2.1. And that will let you download a deb file which will work with Sonic Pi on a Raspberry Pi. It'll work on a Pi 2, although very, very sluggishly and rather slowly. Quite a bit better on a Pi 3, even better on a Thrive Plus, and of course very well indeed on a Pi 4. And if you've got the 4 GB version, then you can run several other programs at the same time. You can see I'm running Sonic Pi here on it, and we're also running the web browser at the same time, and it's not even blinking about it. I've got the CPU usage running top right here, and you can see it's just scraping around down the bottom. And I've got a reasonable temperature, I think in the 30s on up there, because I've got a fan running on my Raspberry Pi. So anyway, there are 3 files on this web page. The first one is a README file that says a bit about the deb and also about how it can coexist with the one which is supplied with Debian. And you may say, well, why do we want another one? Well, there's 2 reasons. The one in Debian is based on version 3.1, and this is version 3.2.1, which has got several new features in it, not least of which the new visualizer. But secondly, the one which is supplied with Raspbian has got 2 serious deficiencies in it. It doesn't support any MIDI input or output, and it doesn't support any OSC signals in or out. And this, to my thinking, is a severe limitation on it, because a lot of the projects which I've done, particularly on a Raspberry Pi, have involved using Sonic Pi to interact with devices connected to my GPIO pins on the Raspberry Pi. And so, for example, I have it connected to a touch-sensitive keyboard, think a bit like a Makey, and I've also had it connected to the Christmas trees, which are produced by the Pi Hut, both the monochrome one and the multicolored one. And I did a project at Christmas which played Christmas carols and flashed all the LEDs in synchronism with the signals coming from Sonic Pi. And I've also used it with various other LED displays as well. And also, of course, with the Theremin project, both the one which is on the Raspberry Pi forums code projects, but also on a modified one I did, which used a time of flight sensor, and that enabled much more precise control than the ultrasonic sensor, which is a bit too crude to do this well. Any rate, be that as it may, if you download this, you have got full OSC and MIDI functionality. The functionality is exactly the same as if you were running it on a PC or on a Mac. And so if we go back to the previous page on the browser, you can see also that there is a pictorial install helper file. This one, the Microsoft Word there is just because I happen to use Word to generate the PDF file here. But it has lots of pictures in it helping you to see what to do. In fact, the first couple of pictures are just to do with um, either disabling or removing the existing Sonic Pi that is supplied with um, Raspbian, but you can leave it there. They will actually coexist, and you can, if you're very careful, run them both at the same time, provided you start the one supplied with Raspbian first, then the 3.2.1 second, because it has got built into it the fact to reallocate the ports it uses if it finds something else is already using them, which is pretty mind-boggling, but does allow this to work. But I wouldn't recommend trying to use them both at work, both at once, because there are one or two slight issues, and I think one at a time on a machine is okay. Anyway, below that, there's just a section about making sure your Raspbian is up to date using the standard commands for that, which is sudo apt update and sudo apt upgrade. And then below that, we have got the installation. And having downloaded the deb file, all you have to do is to double click on the icon, and it then asks, do you want to install it? You click on install, and it then asks you for the password for your Pi, for the Pi user, and you type that in and click on OK again, and in under a minute it is fully installed and ready to go, and it will appear on the menu. We can show it to you on the menu here because this has had this installed, and it appears on the programs section down at the bottom there. I won't click it again because it's already running. Right, so that's that section, and then just to show you, we will download it. It is downloaded already, but if I click on that, you can see it downloading. Takes a few seconds to do so, and there we have it downloaded. And if we were to open a browser, there it is. If we go to the downloads, it's best to look at this using icons. There's quite a lot of stuff on here in my Pi here, so don't worry about that. Let's just go to the downloads folder, and you can see I've actually downloaded it for, so this is the second one that's there. But there's the file, sonicpi-3.2.1_3, and then it's got .armhf.deb. In fact, there's three of them there, because I've obviously demonstrated this more than once before. There's the original one, and all you have to do is to double click on this to start the installation process, which is going to come up here. Now, I've already got this installed, so I'm not going to do it again. I'm going to cancel. Just one other thing to say is you have got to be connected, obviously, to the internet to do this, not just to download the file, but also because it will put in a couple of extra packages as well automatically were I to click the install button. So it's as easy as that, and we can shut that down again now. We can minimize our browser, and we're then back to the running Sonic Pi 3.2.1, and if you look down on the bottom of the bottom right of the screen there, now that may, I think, be hidden by my I think from the way I set this up, I've got the let's just have a look. If I can come down here, yeah, I've got the that on top of it, so let me just move it across a minute, and hopefully if we go to the right screen, which is that one, that may have moved it there, and you can see down here in the bottom that it says Sonic Pi 3.2.1 on Raspberry Pi 4B. Now I'm going to go back to there because I actually want to park that in a suitable place down the bottom right of the screen there, and hopefully that is still visible. I'll just perhaps come up and have a look, and the output's going off to, oops, no, it's gone on the left still. Let me just see if I can move that back down again. It's not moved back. Well, it's probably just taking a bit of time to catch up, actually. We'll leave it there. It doesn't really matter. Right. We'll just leave it there. It doesn't really matter. And we'll just come on and start some music as I intended to do. Um, and to do that, we're going to change to a different channel. First of all, we could perhaps just look at this one. This is one of the built-in um, examples, which actually I wrote, and it was written quite a few years ago. One of the very first things which I did on Sonic Pi when I was just starting off with it, but it does play quite a nice bit of Bach, as we can hear here. Raise the volume a bit. And you can see the visualizer working really quite nicely on this. So there we are, and that played quite nicely. Let's see what else I've got on here. That was actually from a video I did not so long ago. If we make that a bit smaller, and this was actually a program which allowed me to interact with um, OSC controls, and I was controlling some LEDs which were on a screen, which were on a circuit board connected to the GPIO pins. And there's a video of this in my channel on RBN1 Tube on YouTube, and you can have a look at it there. That is a little program which lets me play with a keyboard into Sonic Pi, and again I've demonstrated that before. We'll just go to that one. Where's the one I actually want to do? Here we are. We're going to actually play a bit of a bit of Bach, because that's what it says at the top of the screen here. And I'm going to use a command in in Sonic Pi, which is run_file. And the reason I'm using this is that this is quite a long piece, and there's a considerable amount of data for it. And in fact, there's too much data to fit into one of the buffers on Sonic Pi. But luckily, Sonic Pi has this run file command where it can actually take a file and of code for Sonic Pi, and it can run directly from the file. I could perhaps just go and have a look at that and show you the relevant file for this. If we come down here and I go to my documents folder, which is here, there's a folder in that which for historical reasons is called SP from XML, principally because I quite often used a format of MIDI in XML. I convert Sonic Pi using an XML file into a format which I can feed it into Sonic Pi. This is MIDI files, and in here I'm just going to go here so that I can find it more easily. I think the file that we've got down here is yes, it's the Bach double violin concerto first movement. So let me come down here to where it is, Bach double violin concerto first movement, and I'm going to open that into a text editor. which is here. And you can see that the program is actually quite boring. It starts off putting a little bit of reverb around the whole thing, uses the synth blade for the first part, and the first part consists really of a couple of lists. The first one, the A list, is going to contain all the notes and rests, and the second one, the B list, is going to contain the durations of all those notes. And then at the bottom I have a little loop. It is just going to choose corresponding pairs of the notes and the durations and play them, and then sleep for the duration of the note and go on round that until it's finished. And that is the same for the other parts. I think there are something like, how many is it? 7 parts in this, and that's all that there is in that file. But it is rather long. I'm not sure there's a text wrap option in this. I can't remember. Document, is there a word wrap option? View. Maybe not. I didn't actually do this in this particular editor, so I can't remember if there is one. As probably is in preferences. If I go down here, is there something on editor for wrap long lines? There is indeed. So if we go down there and we do that, it doesn't seem to work. Oh well, I'll leave that for the moment, and we'll just close that off, and we'll close that off, because there is the path to the file, and we'll just sit back and relax and listen now to some Bach played on Sonic Pi 3.2.1 running on a Raspberry Pi 4. Stop that. I went and somehow typed OBS in there. I'm not quite sure how that happened, but let's just start it again. A bit better display now. Just leave you to enjoy this for the moment. Sorry, I got called away there. Just hearing the news about our Prime Minister, and would wish him well for a recovery. Um, just going to start off the second movement of this playing. Here we go. Change that to 2. Um, 2. And start that playing. Let's see. Here we go. Right. Slow movement this time. may be live in the techniques that I've used to generate these files, because I certainly didn't in this case type in all the notes. It started off with a MIDI file, which I put into MuseScore. I then separated the parts, and Sonic Pi is fairly stringent in what you can actually put into a particular part. Although it can play chords, it can't easily play chords where either notes are tied or perhaps one note changes before another one does. And so there's a certain amount of editing that needs to be done. And typically, for example, if you're playing a piano part or a harpsichord part, you might have to split it up into, say, 5 or 6 different parts if it's got intricate chords built into it. However, once that's done, you can then produce easily in MuseScore separate MIDI parts, and then these you can then export as music XML format. And I then have a script which is written in processing, which came from a Japanese friend initially, and this I've modified, and I use it quite extensively to turn these MIDI files, these music XML files, which are exported into Sonic Pi code. And I showed you a bit earlier in this stream the sort of format which is produced. Quite often I modify them, but in this particular case I don't think I had. Essentially, if we go back to the code for this one, it's in the documents folder, you'll see the name for this folder up here, which is SP from XML. Actually, I'm just going to leave that for a second, because we finished the second movement and we'll start the final movement playing, which is a much faster movement after the second movement. So we've changed the 2 down to a 3 here, and I'm going to start that final movement playing now. Here it goes. So back to the folder. So SP from XML was Sonic Pi code from Music XML. That's the folder got its name. And if we go down to where the code is for this one, it's a double violin concerto. We're now in movement 3, so let's just open that up in the text editor. And here is the code, and you can see the sort of thing that's produced. Each one of the parts will produce a hunk that looks a bit like this. You can see it's not actually been formatted because it's not been through the through Sonic Pi as I'm not sure I'm going to get this going. Well, you get the idea. We start off by having arrays for each part. This is the second part. There is a list A, which is going to have either one or maybe just one. In fact, in this case, just one, I think, because there's no changes in tempo. But if there are changes in tempo, there can be subsections to this. This has got, oh yes, there is, because there's, we've got something at one tempo in A2-0 and R2-0. This was just actually a rest, because you can actually play all of these 3 files automatic together, and this was just to give a brief rest between the 2 parts, I think. And then it starts playing, and you can see a list of notes. You can see that there are chords in this part. There's an A4 and a G5 played together, an A4 and a G5 played together again. And then you can see that we simply use a simple Sonic Pi play command. A2IJ will contain a note. We sustain it for the duration of the note, 90% of the duration of the note. We release it for 10% of the duration of the note, and it's got a fixed amplitude. And I've actually got different pan settings for different parts so that they are separate in the audio field, and you can hear them more distinctly. So there's just lots more of that for the other parts in this case. I think there are about 8 different parts, 7 different parts in this one. But that's why the file's so long, and why it can't run directly in a Sonic Pi buffer. but has to be played using the run file command. But it does give quite a nice effect for this. I think I ought to play with the resolution a bit more than this, although it's working here, it's not really optimal, but for first efforts it's not too bad. We'll get there eventually, but it's quite a lot to think about when you're setting these up. I've got, for example, 2 different audio capture cards needed for this. One which is exporting decent audio from the Raspberry Pi, and the other of which is inputting that audio back into the Mac. And I've also got then VNC viewer running to get the picture on the screen of Sonic Pi. So there we come to the end of that bit of Bach, and I hope you've enjoyed listening to that. And we will now get to I think probably the end of this shortish transmission, and I'll go and review it and then come back with some further stuff on another day. Thanks very much, if anybody has been, for watching.